Hello, what's going on? This is Fu and welcome to Algorithm Daily. I'm going to do something special today because I'll be teaching it in English. I think it'll be useful because the programming languages are written in English, so more or less you have to deal with it in an English environment. But I'm not sure if it's a good idea or not, so please comment below and let me know if it helps. So let's get to know the question. The question we are doing today is LeetCode 382 linked list random node. Given a singly linked list, return a random node's value from the linked list. Each node must have the same probability of being chosen. There is one follow-up. What if the linked list is extremely large and its length is unknown to you? Could you solve this efficiently without using extra space? So the key points of this question is first, same probability of returning. Second, can you solve it without relying on the size of the list? For this problem, we can think of it as a lottery game. Like for example, if we are doing a lottery game like this, and we have a list which have an elements of 1, 2, 3, and so on. And each element is represented by its index. So if you have index 0, 1, and 2, and so on. We have a variable to calculate the current size of the list. And we will have a button. For example, if you're doing a lottery game, when you push a button, it will return a random number that represents the number, for example, the index. And we will have a winner. So initially, because the size of the list is unknown to you, so we start from the very beginning of the list. If there is only one element in the list, which is 1 here, right? So the current size is 1. And when you push the button, it will return a random variable up to the size of the list. In this case is from 0 to 1 exclusive. Right? So if it's returning an integer, it will be always returning a 0. So the winner will always be 1 if the size of the list is only one element. And if there are more elements in the list, you need to take a look at each element of the list because each element has the same probability of returning. So each element have a chance to play the lottery game. So for example, if we have 2 elements of the list, for the second element here, we need to play the lottery game procedure again. So the current size will become 2. And when you push the button, it will return a random variable up to 0 up to 2, right? Exclusive, which means the returning integer will be 0 and 1. 0 represents the first element, the 1 represents the second element. So if the button return value is 1, then the winner becomes 2. Otherwise, it will stay as 1. And let's play one more time for the third element. And the current size here is 3. And when you press the button, it will return a random variable up to 3, which means the returning integer is 0, 1, or 2. So again, if the button's return value is either one of these index, for example, if the index is 2, when we are looking at the third element here, then the winner becomes itself, which is 3. So in this procedure, we are guaranteed that each element has the same chance of playing the lottery game, so it guarantees the same probability of returning. Okay, so this is the general procedure to solve this problems, and now let's take a look at the code. First, we need to have some variable, for example, a list node to store the list somewhere, right? So in this constructor, we save the list. Initially, the winner, let's say the winner, is the first element, which is head.value. And we need to iterate through the list because we are not sure the size of the list. So we need to iterate through each element of the list. We set a current pointer, which points to the head, and then we iterate through each element of the list, starting from the second element. If current.next is not null, then we move to the second element and let the second element place the lottery game. For example, if we have a function called get random number and we pass in the index, here index plus 1 means because I here representing the size of the elements, so the index of the element. So index 1 means we have size of 2, means there are 2 elements in the list. So here, that's why we have I plus 1. If the returning, remember here, when we press in the button, which is we are calling this get random number function, if returns a index is the current number's index, which is I, that means the element wins the lottery. So we need to replace the winner to the current element. And then so on and so forth for the rest of those elements. So in this way, when we finish iterating the list, then we just return the winner. And we need to write the get random number function, which is how we operate when pressing the button. It takes in an integer, which will return a random value that is between 0 up to the size of the list. We can use math.random, and we times n, and we need to cast it into an integer. I explain it a little bit. For math.random, its return a value is between 0 to 1, exclusive, right? So if we times, for this times an n, it will return a value between 0 to n, right? And if we cast it into an integer, so here times an n, it becomes this procedure. If we cast it into an integer, which we will have inclusive at the end, it will be 0 to n minus 1. For example, if we are having 2 elements in the list, so the n will be equal to 2, so we will be returning a 0 or 1. If the index is 0, that means we are getting the first element. If the index returning is 1, that we are getting the second element. So that's how the button procedure plays, which is how we get the random number here. So we're gonna run this and see if it has any errors. Okay, finish. Looks okay. And we're gonna submit the solution. All right, accepted. So this is how we solve this question. The key points of this questions, like I said before, is first, same probability of returning, and the second is, can you solve it without relying on the size of the list? And we can think of it as winning a lottery game. To guarantee the same probability of returning, we need to enable each element to have a chance to play the lottery game so that each element will have a chance to be returned. Okay, that's it for today's problem. Thank you. Remember to comment below if you like it or if you think teaching in this way is helpful for you or not. Thank you.